The motivation behind using MST is to have larger networks with more VLANs enabled and consume less switching resources but still provide a loop-free topology. As you can see in the example above, I want to load balance 1,000 VLANs across 2 links. In order to do this, I'll use 2 MST instances, grouping 500 VLANs in each instance, which means I only have 2 instances of spanning tree running, where with other protocols I would have 1,000 instances of spanning tree running. In this scenario, each switch maintains only 2 spanning trees, reducing the need for switch resources. I can take the same concept and expand it out to 4,096 VLANs and provide VLAN load balancing across multiple links. MST is backwards compatible with 802.1d and 802.1 Rapid Spanning Tree Protocol. This is an example of how I would configure the instances. On the upper left-hand corner, you can see that the upper left-hand corner switch is the root of instance 1. In the upper right-hand corner, you can see that that switch is the root of instance 2. Therefore, to the switch below, I am able to load balance instance 1 up the left link, where instance 2 is blocked on the left link, and I can send the rest of my VLANs with instance 2 up to the right switch, while instance 1 is blocked on that VLAN. Once again, switch utilization is low because it only has to handle 2 separate instances, where with other protocols there would be 1,000 separate instances. There are some considerations with MST. MST has great scalability and should be used in large environments, but in smaller and larger environments, MST is more complex than 802.1d and 802.1w, so it requires additional training, and interaction with legacy devices can be challenging. In order for MST to be running on a switch in the network, it has to have 3 different attributes configured. One is a name, the second one is a revision number, and the third is that your VLANs have to be associated with an instance. By default, they're associated with instance 0. It's worth noting that MST carries the instance number and the 12-bit extended system ID field of the bridge ID, as seen above in this picture. Please join me for the next lesson, Understanding PVST+.